Hi guys, I'm Sai Krishna. So let us look at question number 2. In question number 2, we are given three functions, and yes, we are told that the three functions of V do they represent either autocorrelation function of WSS or spectral density function of spectral density function, or both. So let us look at how to solve this problem. So question number 2, so let us look at part A first. So for a function f of v to be an autocorrelation, uh, we do know that there are two conditions. One is that it should be even, the Fourier transform must be non-negative, and also r of tau must be less than or equal to r of 0. This is for autocorrelation function. These are the necessary conditions. So for a function for spectral density for a function to be spectral density, the function must be greater than or equal to 0. So in part A, we are given f of v as e to the power of minus mod v. For this function, we can clearly see that it's an even function. So this has been satisfied. So let us look at the Fourier transform. The Fourier transform for this equation becomes 2 alpha by alpha square plus omega square. This is also non-negative, so this is also satisfied. So let us look at this one. For r of tau less than or equal to r of 0, this means that e to the power of minus mod v is less than or equal to e to the power of 0. So we can clearly see that this is also satisfied. So we can clearly say that f of v in this case is autocorrelation. So so f of v can be an autocorrelation function in this case. For a spectral density function, it can also be a spectral density function as e to the power of minus mod omega in this case is greater than or equal to 0. So in A, it can be both autocorrelation as well as it can be an spectral density function as well. So let us look at part B. In part B, f of v is given to be sine square of v by v square. As this is an even function and this is an even function, so as a whole f of v is an even function. So first condition has been satisfied. So coming to the second condition, we can clearly see that sine square tau by tau square is less than or equal to limit t tends to 0. I'm basically substituting 0 here. So sine square tau by tau square, here this value becomes 1. So here sine square tau by tau square is less than or equal to 1, which has been satisfied. So it can be said that this is a spectral this can be an autocorrelation function. So let us look at whether it's a spectral density function. It can also be a spectral density function as sine square omega by omega square is greater than or equal to 0. So it can be both autocorrelation as well as spectral density function. So let us look at part C. So in part C, we are given f of v as 1 when mod v is less than or equal to alpha, 0 when mod v is greater than alpha. So in this case, we can clearly see that the Fourier transform in this case is 2 sine alpha omega by alpha, which is clearly a non-negative. So here the Fourier transform is not non-negative. So hence it cannot be an autocorrelation function. This cannot be an autocorrelation function. So f of v is clearly it can be a spectral density function, as f of omega is greater than or equal to 0. So it cannot be an autocorrelation function, it can be a spectral density function. This is how I've solved question number 2. So thank you.